Okay, in this problem we're being asked to solve the triangle and determine if there's two triangles or just one. So, all right, so let's just kind of think about whether there would be one or two triangles. This kind of goes back to the unit circle. So remember that sine is the y value. So sine at 90 degrees, that's the y value of this terminal point. So that would be 1. Now the sine of some angle, if that value is anything between 0 and 1, there's two different angles that would produce a sine value between 0 and 1, because you could have the y values here are going to be the same as in quadrant 2, okay? So supplementary angles have the same sine value. Okay, so let's say that we have that angle 1 and this was angle 2. The sine of those, angle 1, are the same. Okay, and those are supplementary angles. So 180 minus angle 1, that's what angle 2 is worth. All right, so just knowing that is going to really help us go into this next section where we're looking at the ambiguous case with triangles. Okay, so we're going to keep that in mind, and we're going to try and figure out if this has one or two triangles possible. Okay, here we go. So I'm not sure what this looks like, but I know that, okay, I'm given an angle 32 degrees, so this is B. I'm going to first just convert that 42 minutes. If I divide 42 by 60, that gives me 0.7. So it'd be, I'm just going to convert that to decimal degrees. Okay, so let's do that first. So that's 32.7. And I know that I have two sides and an angle. Side angle, and that is the ambiguous case whenever we have that situation. Okay, so I'm looking out to figure out one or two triangles. Okay, so the side across from B is side B, and that's 30.8. I'm going to just let this be angle A, and that's 30.8. Okay, so let's say sine of A over its opposite side, so over 30.8, is equal to sine of B, which is 32.7 degrees, all over its opposite side, which is 30.8, multiply, oh, I wrote that down wrong. Let's see, A is 37. Let me fix that. This is 37.5. Okay. And now we just multiply both sides by 37.5 to solve for angle A. So that would be 37.5 times sine of 32.7 degrees all over 30.8. Okay, now when I pull up my calculator and figure that out, I get that the sine of A is approximately 0.6577601. Now, that is an angle that is less than 1. So that tells me I've got two triangles possible. Okay, so our calculator, when you take the arc sine, it's always going to give you the acute angle. Okay, so we're going to use, this would be angle 1, and this in here, that angle is A2. Okay, and that one we'll just use supplementary angles. So angle A1 would be what comes out of your calculator, 0.6577601. So angle 1 is approximately, now this is where it gets a little bit funny because you have to be really, really exact here and do all those 7 decimal places. But when you pull out your calculator and do arc sine, you only need to round it to one place. So that's 41.1 degrees, and then rewriting that as minutes, that would be 41 degrees, and 0.1 times 60 is 6 minutes. Okay, so that's angle 1. Now, angle 2, you can see here, if this is 41, these angle side or these sides are the same. So that little triangle has this is A1 as well. And then you can see that A1 and A2 are supplementary. Okay, so our first angle we get by finding the arc sine, and then our second angle we get using supplementary angles. 180 minus A1, 41.1, which is 138.9. Okay, so we're going to use that for our second triangle, but let's just work on the first triangle. Okay, so the first triangle, again, I'll just kind of draw it here. It looks like this, where that's B, there's A, there's B, there's A1, and here's C. Okay, we need C. And so angles within a triangle add up to 180. So we've got, let's see, angle C would be 180 minus what we have. We have B, which was 32.7, minus angle A, which we found to be 41.1. Okay, so angle C is, let's see, 106.2 degrees, and then that would, in terms of minutes and degrees, it's 106 degrees. 0.2 times 60 is 12 minutes. Okay, and then the other part we needed was we need to find side C. Okay, so let's see, this we're going to save, that's for our second triangle. Okay, so we'll come back to that in a second, but we need, let's see, we need side C. Okay, so we're going to find, we want C, we'll put what we want in the numerator, and then that needs to go over the sine of angle C, which we found is 106.2 degrees. And let's use B over sine B, so 30.8 over sine of 32.7, and multiplying both sides by sine of, let's see, times sine of 106.2 would solve for C of 32.7. So, okay, so I get C is approximately 54.7 or 0.47, 54.747, and so let's see, the correct answer according to my lab is 54.8. So there's a little bit of rounding error on that. So if I had gotten that wrong on the homework, you know, I can just send myself a little picture and say, oh, I think there's a rounding error. Okay, so just don't get discouraged. The rounding can be really tricky on these, to try and figure out how the person who wrote the answers was rounding. Okay, so that's triangle 1. Now we need to work on triangle 2. So triangle 2 looks like this. There's our B, but this time A1 is, or A2 is coming in here, where this would have been A2, or sorry, A1 out here. Okay, so this is A1 in here. This is also A1. Let me make it a little bit better. Okay, so in here, this is A2. And A1 and A2 are supplementary angles. We already found up here what A2 is worth. So we have that A2 equals 138.9 degrees. Okay, and now we can have, we've got a different angle C. So B is the same. That was 32.7. Okay, and then C would be 180 minus those 38.9 minus 32.7. All right, and we get 8.4 degrees, and then rewriting that in terms of degrees in minutes, 0.4 times 60 is 24. So it would be 8 degrees, 24 minutes. That is our angle C right in here, okay? And then we just need side length C, which is going to be quite a bit shorter than our C1. So this is our C1. So this is C2, and so just like we did before, we'll set up what we want. This was C1 we were finding. Okay, so the C length for triangle 2 is side length over sine of angle C, so sine of 8.4 degrees is equal to side length B, which didn't change, 30.8 over sine of B, that didn't change, 32.7. Okay, and then we'll solve 30.8, multiply both sides by sine of 8.4, all over sine of 32.7. And we get that C, oh, this is C2, C of triangle 2 is 8.3. All right, okay, so big picture again, if you have two sides in an angle, side-side angle, that's where there's potential for two different cases, okay? So we keep in mind that if what we come out with is a sine value that is between 0 and 1, then we have two triangles, and we use the fact that supplementary angles have the same sine value, okay? So the first one we're going to find by using the arc sine, okay? And then the second one we're going to find using supplementary angles, okay? And then we'll just go through the process of finding that additional side C on both. Okay, so these are definitely, you got to kind of keep straight. I have to draw a couple diagrams to keep it organized of what I'm looking at. Okay, so the one that comes out from, let's see, I'm swinging around, sorry, I'm making you dizzy. The one that comes out from your calculator is that acute angle, and then you need to find the second triangle using supplementary angles.